Hi everybody! So today is Monday, January 22nd. So today we will finish 7.1 and then start 7.2. So this week you don't have any homework due yet. Our first homework assignment is due next Wednesday. And it's due, it means you need to submit your first attempt by this deadline. And then after the Wednesday, you can still continue to work on your homework to increase your scores. Right, everybody? You have unlimited attempts. Okay, so let's see. Bless you. Okay, last time we talked about anti. Okay. Yeah. All right, let's charge. Okay. All right, let's see. Okay. All right. Last time we talked about how to find the antiderivatives. And let's review the formula again. Remember, there are four formulas we use. The power rule, the integral of x to the t is we increase the power by 1 and then divide it by the new exponents. Right? Do you remember? And if we have exponential function, or e to the ax, or integrate is e to the ax over a plus c. And integral b to the x. I see a typo here. This should be b to the x. Okay. Paste. So integral b to the x is b to the x divided by ln of b. And then integral of 1 over x is natural log of absolute value of x. Right? Okay, let's continue to work on example 5. Oh, okay. So let's look at this first. So in apply count 1, we have the displacement, and then we take a derivative, we get velocity. And then we take another derivative, we get the acceleration. Yeah? And now after we learn integration, we do the reverse order. If we're given acceleration, we integrate to get the velocity. Yeah? If we integrate the velocity, we get displacement. But because every time when you integrate, you get a family of antiderivatives, plus c. So we need to plug in the initial condition. Like sometimes they might give you initial velocity, sometimes they will give you initial displacement. So you plug in the initial condition to find the constant c and d. So you can find the correct antiderivatives. Yes. Okay, so let's look at our example 5. So a particle moves in straight line and has the acceleration given by a of t is 6t plus 4. And we know the initial velocity is negative 6 centimeters per second. And its initial displacement s of 0 is 9 centimeter. Find the position function s of t. Okay, so we start with the acceleration. So something wrong with my word. Okay, let me draw it. Can I draw it? Okay, yes. So a of t equals 6t plus 4. This is acceleration. We want to find the velocity is the integral of acceleration. So integral of 6t plus 4 dt. What is the integral of 6t?
Oh no, 6 times 2t
The t square
over 2.
over 2, yes. And how about the integral of 4? 4 times c, yes. So when we integrate the power function, the power increased by 1. So that's why, it's linear, degree 1. Oh, power increased by 1. Oh, it becomes degree 2. Oh, but you also need to divide it by the new exponent. It was constant. Oh, it will increase the power by 1 and then we get a linear. Yes. And after we finish, remember your cell phone, right? Plus C. Can we simplify? 46 divided by 2? 3. Yeah. So this is 3t squared plus 4t plus c. So this is v of t. Do you see the problem? We have initial velocity. So we can actually plug in v of 0 equals -6 in here. Then we can find the c. This is unlike our previous example. Do you remember this example? Oh, I have two conditions, but both of them are f. Yes, both of them are f. So, but we're giving f prime prime. So you integrate the first time, you get f prime. Can we plug in here? No, we have to continue to integrate one more time to get the f, and then we plug in both conditions in the f. But this problem, our initial condition, one of them is about v. So we can plug in the v of 0 here to find the c. We don't have to integrate 2 times to get the displacement and plug in the c. Yeah. Okay, so we plug in v of 0 is -6. So v of 0 is -6. On the right-hand side, we plug in t is 0. So t is 0. T is 0. But 0 to the whatever power except 1. 0 to the whatever power except the 0. So 0 to the 0 is defined to be 1. But 0 to the other power is 0. Right? So what is your right-hand side? Just the c. So c is -6. So let's rewrite it. Velocity is 3t squared plus 4t. And then c is -6. Okay, now it's your turn. Please integrate the velocity to get the displacement. So integrate that, get the displacement, plug in the initial displacement to find the d. So I took the attendance after 10 minutes of the class starts. Let me see. So this is the attendance sheet. Please sign your initials. This is second week Monday. All right. Are you ready to check your work? Mm-hmm. All right. S of t is integral of the velocity. So integral of 3t squared plus 4t minus 6 dt. What is the integral of 3t squared? T cubed, yes. So t cubed. Everybody okay with that? Yeah, 3 times t cubed over 3, 3 and 3 cancel. We get t cubed plus integral of 4t. 2t squared, very good. 2t squared. And then minus 6t after you finish plus, and because we already had c before, so we want to use a different constant. So you can choose D or any other letter. Yeah. All right. So we plug in our initial displacement. S of 0 is 9. So on the left-hand side, we get 9. But on the right-hand side, what's 0 cubed? 0. And then 2 times 0 squared, also 0. Minus 6 times 0, also 0. And plus D. Oh, what's D? 9. So finally, S of t. So we write it t cubed plus 2t squared minus 6t. And then d is 9. So this is our final answer. Make sure you write down your final answer and you copy your d. D is 9. So far, so good, everybody? Mm-hmm. Okay, so that is the acceleration, velocity, and displacement. You see that in a physics class. Oh, do you need to take physics class or you already took? Not yet. Do you need to take it? No. Oh, okay. All right. Example 6. Because of insufficient oxygen supply, the trout population in the lake is dying. Oh, sorry about that. The population's rate of change can be modeled by the following. So P is the population, and this is the rate of change. So that's the derivative of the population, right? And it's negative because the population is decreasing. That's why it's negative. When T is the time in days. So when T equals to 0, the population is 3,750. So this is the initial population, right? So we have population function P. This means P of 0 is 3,750. Find the rate when T equals to 10. What does this number represent? Okay, so part A, dp dt, the rate of change when t is 10. So this step, do we need to integrate the rate of change? No. We just plug in t is 10. Yes. Okay, so we get minus 250 e to the negative 1 over 10 times t. T is 10. Hey, everybody. So in this course, please bring your scientific calculator. Because in this class, you will see a lot of application problems. Application problems involve a lot of hard numbers to calculate. So please bring your calculator all the time. And do you see 10 and 10 cancel? We get minus 250 times e to the negative 1. To put this in your calculator, what did you get? 90. Oh, you mean negative?
Oh, yeah, negative.
Negative 91.17?
Yeah.
Yeah, okay. Thank you. Okay, so this is, let's round this to whole number because it's the number of the fish. Yes?
Oh, I think you messed it up. Yeah, I
Oh.
think it might have missed her.
Oh.
Yeah, it's negative 91.
97. Oh, sorry. My bad. Okay, 91.97. Thank you. Okay. So this means is about equal to minus 92, right? So it means the rate of change is negative 92. So the population decreases by, because it's negative, so decreases by 92 per day. So this is what it means. The rate of change is negative 92. So the fisherman decreased by 92 per day. Okay, that's part A. Part B, let's find P of T. Well, P of T, because we're given the rates, so P of T is the integral of the rate of change, dp dt, and that is negative 250 e to the negative 1 over 10 t dt. So we want to integrate that. All right. So exponential function. What is the rule for exponential function? So integral e to the ax is what? Be familiar with the formula. What's the integral of e to the ax? Yes. So e to the ax, and then we divide it by a plus c. Right? Remember, father looks like the sun, but the more done, put it downstairs. E to the ax is still e to the ax. Do you need to subtract 1 or add 1 to the exponent? No. Okay? Exponential function. The exponent stay the same. Not like power function. Power function x to the n. When we take the derivative, the power decreased by 1. When we integrate, the power increased by 1. But for exponential function, the exponent always the same. Okay? So when you take the derivative, what? You multiply by a. So when you integrate, you divide it by a. Yes, everybody? Okay, so we follow that rule. So we get minus 250, constant multiple, stays here. Then exponential function e to the minus 1 over 10t. By comparison, do you see the coefficient of the t is like the x, that's the variable, right? And then the coefficient is the negative 1 over 10. So you want to put the entire negative 1 over 10 downstairs. So negative 1 over 10, move it downstairs. Okay, do you see the negative cancel? You divided by 1 over 10. That is the same as multiply by. Yes, everybody, the divide by a fraction is the same as multiply by its reciprocal. The reciprocal is 10. So 250 times 10 becomes 2500 e to the negative 1 over 10t. Sorry, I forgot what? My cell phone. Yeah. You need the cell phone plus c. Okay. That is P of t. How can we find the c? Use initial condition. Yes. So we plug in P of 0 is 3750. So 3750 equals, here we plug in T is 0. Oh, do you see like the last problem where we plug in the initial condition? Because we had power function. For power function, when you plug in 0, they're just gone. And we just get C is the initial condition. But in this problem, when you have exponential function, you gotta be very careful. Because e to the 0, is it 0? No. E to the 0 is 1. Oh, so we got 2500 times 1 is 2500, and plus C. What is C? Yeah, exactly. Very good. We move this over, we subtract 2500, we got 1250, right? That's our C. So our population is 2500 e to the minus 1 over 10t plus C is 1250. So this is part B. This problem has a lot of parts. So you want to write tiny. If you run out of space, you can. Do you have a space on the next page? Okay, good. Okay, so this is PFT. Part C. What is the population after 15 days? So you plug in 15 into the population function. Yeah, everybody? So plug in 15. 2500. E to the negative t is 15. 15 over 10. And plus 1250. Okay. So population, their whole number. So round your answer to whole number. Did you get? Everybody? Oh, you already got that? 1808. Okay.
What is it? 15 over the 10?
Oh, the T. So we plug in T.
Oh, there's a T. Okay.
Yeah.
Okay.
Yeah. I put 15 over 10 is that 1 over 10 times 15. Yeah. Okay. 1808. This kind of makes sense because remember the population is decreasing. So after 15 days, we only have 1,808 trials left. Okay, so that is C. Any question about part C? Okay, D. According to this model, how long will it take for the trout population to reach 1500? So part D, we're looking for the time such that our population at that time is 1500. Right, everybody? Okay, so I hope you have enough space because I don't. Let me shrink this so I can have some space here. Or you can go to your back side of your worksheets if you have your next page. Okay, so let me use a different color. How about purple? Okay, so we want to solve for T. Our population function is here, right? This is the population function. We want to set this equals to 1500 and solve for T. Okay, so let me make it bigger. And okay, all right. So P of t, 2500 e to the negative 1 over 10 t plus 1250. Set this equals to 1500. Our goal is to solve for t. We do? Yes, minus 1250. This is the equation involving exponential expression. So the first step, we want to isolate the exponential expression. Isolate means we only want to have the exponential expression on one side by itself. So it means I want to get rid of the 2500 and the 1250. Which one do you get rid of first?
1250.
Yes, exactly. So subtract 1250 on both sides. So we get 2500 e to the negative 1 over 10t. What is 1500 minus 1250? 250. Good. What do we do next? Yes, good. Yeah. So on the left side, we got e to the negative 1 over 10t. On the right-hand side, what's left? 0.1. It's actually 1 over 10, right? Okay. Once we isolate the exponential expression, we want to get rid of e. Remember exponential function, the inverse function is natural log, right, everybody? So we apply natural log on both sides. So we apply natural log on both sides. So we get ln e to the minus 1 over 10t equals ln 1 over 10. And you know, ln and e, they are inverse function, they cancel. We get minus 1 over 10t equals ln 1 over 10. And then what? How do we solve for t? What? Yeah, multiply by the reciprocal, which is, yeah, minus 10. Very good. So we multiply by minus 10. Multiply by minus 10. And this cancel. We get t is ln 1 over 10 times negative 10. Questions? Can I cancel this 10 and this 10? No. This 1 over 10 is inside the natural log, so we cannot cancel it. Okay, so put this in your calculator. What do you get? 23rd day. Yes, so that's the answer. Okay? All right. Yeah, so this is a real life problem. We have the population model, and then we can integrate the rate of change to get a population. Then you can ask like two directions. You can find if you know the time, then you can find the population. Or if you know the population, you can find the time. Okay? So this, knowing the time to find the population, you just plug in and evaluate. But knowing the population, find the time, it involves solving equations of exponential function. So this needs more work. In your step, you isolate the exponential expression, and then how do you get rid of that? Apply the inverse function natural log on both sides. Okay. And in this process, I recommend you to use your calculator at the last step. Okay. So in the intermediate step, don't plug your calculator and get decimals because that's not accurate. Only use your calculator at the last step. Then your answer will be more accurate. Okay, so that is 7.1. Any questions about 7.1? All good? Okay, so that's the antiderivatives. Now, let's look at the substitution. substitution. All right. Okay. So yeah, this three formula, keep that in mind. All right, substitution. Okay. So why do we need substitution? The idea is if we look at this problem, if we have x 1 plus x squared to the second, and how do we integrate? Do you remember? We don't have product rule or quotient rule for integral, right? If you see a product, based on the knowledge we learned so far, you need to distribute so you get a sum or difference. Then you can integrate term by term, right, everybody? So, okay, this is a complete square. Remember, a plus b squared is a squared plus 2ab plus b squared? Mm-hmm. And now we distribute the x. It's kind of like increase the power of x by 1. And now we can use the power rule. Okay, integral of x, x squared over 2, integral of x cubed, x to the 4th over 4, integral of x to the 5th, x to the 6th over 6. This is how we integrate. Yeah, based on the knowledge we learned so far. But what if this is not squared? What if this is 15? Oh my god, you want to expand it? No, it's so hard to expand it. So that's why we need the U substitution. And you usually use U substitution when you see a composite function. Do you see here? I have a composite function. I have the inner function 1 plus x squared. And then we have the outer function, something to the 50, right? So we see a composite function, then we use that. Do you still remember I gave you the antiderivative formula in the beginning of the class? This one? Yeah? Okay. So today, use substitution. So this corresponds to the chain rule. Remember when you take the derivative of composite function, you do chain rule, right? You dy dx is dy du times du dx. It's your old formula, and then you multiply by u prime at the end, right? When you differentiate. So, but today, if you want to integrate something that looks like composite function, you have the inner function and the outer function. Then we use the u substitution. Okay, so the U substitution. How do we do that? You let U be the inner function. Okay, then you see U is the inner function. Then you have du dx is g prime of x. U is g of x. When you take the derivative, we get du dx is g prime of x. Mm-hmm. Let's both sides multiply by dx. Then we get du is g prime of x dx. This is called the differential form. So differential form. Okay, we have du on the left hand side. On the right hand side, we have g prime of x. Okay, wonderful. Do you see this g prime of x dx? This is exactly du. Therefore, we can plug in, replace g of x by u, replace g prime of x dx by du. We get a simpler integral about u, right? This is a simpler integral. And hopefully, this integral is one of these 3 times. Then you can use the antiderivative formula to integrate. Right? So one of those 3 types. Okay. So, how do we do it? Step 1, you identify u is the inner function. So the inner function is 1 plus x squared. So are you okay with like how to identify the inner function? If the outer is like, oh, something to the 50, the inner is 1 plus x squared. Anybody? That's step 1. So let the inner function be u. Step 2. Find the differential. So take the derivative on both sides. Left hand side, u becomes du. The right hand side, what's the derivative of 1? Derivative of 1. 0. Derivative of x squared? 2x dx. Yes. Right, in this process, you actually need to differentiate and then integrate. So be careful, do it slowly. All right, let's see. So this is u, right? The inner function is u. So we have u to the 50. Do you see I still have the x dx? You want to express everything in terms of u. So I want to know what is x dx. I don't like the 2. So get rid of the 2. Both sides divided by 2. So then x dx is how many du? 1/2 du. See? We have 1/2 du. Yes. Now I check. I change all the x in terms of u. So in this process, make sure everything is in terms of u. You don't want to see a mixture of x and u in it. That's not allowed. We're still doing a single integral. Later in this course, we will do double integral. So, single integral represents the area under a curve. The double integral, you have 2 variables. It represents the volume under a surface. Okay, so instead of 2D, now you have 3D. It's volume under a surface. The double integral. So yeah, don't get a mixture of u and x in it. It's either everything in terms of x or everything in terms of u. You don't have mixture. It's like you don't drink a mixture of milk and orange juice, right? It will make you go to the restroom. Okay. So now, constant multiple. The 1/2, what do you do to it? Move it outside, right? So the 1/2 constant multiple, we can move it outside. Now, you get integral about u. This is one of those 3 kinds. Yeah? So one of those 3 kinds, either a power function or exponential function or a low range. In this case, u to the 50, which one? The first one. U to the 50, you increase the power by 1. What do you get? U to the 51 divided by 50 plus 1 is 51. The new exponents, right? Everybody? Plus C. Good. Let's simplify. What is 2 times 51? Yeah, 102. So like step 3, you get the integral about u and then you integrate. And step 4, you put the x back. What is u in terms of x? 1. What is u? Yeah, 1 plus x squared to the 51 plus c. So this is the 4-step u substitution. And we can finish in 2 minutes, right? Wow. If you want to expand this is to the 50, it takes days to do that. And I don't want to make it long, right? So the u substitution is very useful, especially when you see composition. Okay. Yeah, so from now on, if you see a product, we don't have product rule, but think about u substitution. Okay. Procedure. Yeah, like I said, step 1, Identify the inner function. That's your U. Step 2, check the derivative. Then you can find the differential form. And the common mistake is sometimes students forget to put the dx. Imagine we have two kids play on the seesaw. Oh, you need to have du and dx, right? Can one kid play on the seesaw? No. So we need differential here and differential there. So don't forget that. And then step 3, evaluate the u integral. It will be one of those three types. Okay, one of those three types.
What about that little X and
Oh, here, x dx.
Okay.
They are together is 1/2 du. Yeah, yes, very good. That's why we replace this by u. What's that? X dx. Ooh, that is 1/2 du. And then after you integrate, plug the x back. So 4 steps u substitution. Okay. All right, let's do a lot of exercise. Okay. Look at this. It's a quotient. Do we have quotient rule? No. So from now on, if you see product or quotient, think about u substitution. Okay. What is the inner function?
X squared plus 3x minus 1.
Yes, inside the square root. So that's the u. So step 1, u is this one, inside the square root. So u squared plus 3x minus 1. What is du? What's the derivative of x squared? Yes, 2x plus 3. Awesome. And remember, we multiply by dx. 2 kids on the seesaw. You need differential on both sides. Okay. Are we ready to plug in? Let's see. Numerator. 2x plus 3 times dx. That is 1 du, right? So the numerator is du. How about denominator? Square root of u. Right? Okay. So here, keep in mind. So we mark du is always on top. It's always in the numerator. It's never in the denominator. Okay, so yeah, be careful. Now let's simplify this. So this is u to the what power? Negative 1/2. Yes. Good. It's u to the negative 1/2. And what's the integral of u to the negative 1/2? That equals u to the our function. If you add 1 to the exponent, what do you get? 1/2. Yes, it's negative 1/2 plus 1 is 1/2. And then you divide it by the new exponent, which is 1/2 plus c. Yes, power function. Add 1 to the exponent. What's the new exponent? Put it down. Okay, what's divided by 1/2? Multiply by 2. So this is 2u to the 1/2 plus c. Last step, get the x back. What is u? Yes, 2 to the 1/2 plus c. That's the 4 steps. So far, so good, everybody? Okay, part B. Part B, what do you want to let x do? Let u do. What do you want to let u? X? Okay, let's think about it. If we let u be x, and what is du? 1 dx. And then your integral becomes x is u, x is u, dx is du. What happens? It's the same thing. You just call it a different letter, but it's the same integral. So we mark never let u be x because you just get the same thing. You just call it different letter, but still the same integral. Mm-hmm. Yes. Okay, so this does not work. Let's try something else. What do you want to let u to be? Yeah, we can try that. So let u be step 1, ln x. Then du is what? Yeah, 1 over x dx. Look at this. So we can rewrite this as integral ln x, and then over x is the same as multiply by 1 over x dx. Do you agree? We can just separate them. Now what is ln x? U, ln x. U. Yes. And then 1 over x dx is du. Yes. See? We get an easier integral. It's one of the 3 types. Again, what are those 3 types? Power function, exponential function, or 1 over x. Only those 3 types. If you don't see those 3 types, something is wrong. Then go back and check the word. Maybe your u is wrong. Maybe your du. Mm-hmm. Okay. So what is the integral of u? Integral of u is yeah, u squared over 2 plus c. What is u? So put the x back. What is u? Yeah, ln x square over 2 plus c. By the way, can I put ln x squared over 2 plus c? Can I do that? Yes? No. Be careful. What does this mean? Well, this usually it would mean is ln of x squared. Oh, ln of x squared, you can move the square in front. So this is 2 times ln of x over 2 plus c. So this is ln x plus c. So they are not equal. The square is the entire ln x squared. It's not ln of x squared entire. So be careful. Don't forget parentheses.
So that last part we don't have to do, right?
Yeah, it's not the same.
Yeah.
They just leave it like that.
Okay.
Yeah. Okay. Let's continue next class. Have a good day.